In this lesson, we are going to review solving two-step equations. So last week we spent time with one-step equations. So we undid by either adding, subtracting, or multiplying and dividing, and we just had the one step. Today we're going to look at two-step equations where you have to do two things in order to get the variable all by itself. So make sure you put today's date in the top left-hand corner or in the top right-hand corner, as long as you're putting the date. So the generic form of a two-step equation will generally look like this. Some number, we'll call it p, times x plus another number, or subtracting another number, equals another value. So we're going to look at the generic form of the equations and look at some actual examples. So to solve this equation, it's very similar to the steps that we took to solve one-step equations. We're kind of just combining the two steps that we've learned into one problem. So the first step is, again, locate your variable. That's really important. So in our problem, the variable that we're most concerned with is x, because we're generally trying to solve for x, some value x. So the first step when you have problems like these is you want to take care of the addition or the subtraction by undoing it. So the second step here is going to be undo the addition or subtraction to remove q, or in our case, the q value. So in our problem, we would subtract q on both sides to get that q out of there. Once you do the addition of removing the addition or subtraction, then you can undo the multiplication or division. And that's going to remove the p-value, or the number that's attached to the x, the coefficient of x. So we undo addition and subtraction first, and then we undo multiplication or division second for equations that look like this. And then last but not least, we always can check our solutions. So whatever value we get for that x, we can plug that in and make sure it gives us the value that satisfies both sides of the equation. So let's look at some examples. Our first problem will look very similar to the problem that I gave you as a generic sample. Okay, so looking at our steps, we locate the variable. So in this case, the variable is a, and we want to undo what's happening to the a. So there's two operations happening to the a. We're multiplying by 9, and we're subtracting 2. So when you're solving equations, we actually go in the inverse order of operations. We go backwards, and we undo the operations that are happening to the a going backwards. So normally multiplication comes first, but since we're undoing things, we're going to deal with the addition and subtraction first. So here, since I'm subtracting 2, I want to undo that by adding 2, and I have to, whatever I do to one side of an equation, I have to do to the other side. So minus 2 plus 2, those cancel out. They give me 0. So I have 9a equals negative 65 plus 2. You can plug that into your calculator. or if you can do the mental math, it's just negative 63. So I undid the addition or subtraction. Now I still have one more step. This is why this is called a two-step equation. The next step, I have to undo the division or multiplication. And since we're multiplying by 9, to undo it, I have to divide by 9. My final answer here is A equals negative 7. So I undid the subtraction, then I undid the multiplication. And that allowed me to get to this problem here of my solution. Let's try another example. Let's do number 2. All right, same idea. We want to undo what's happening to our variables. We locate the variable and we undo what's happening to it. So this one you got to be careful. We're adding 7 and we're multiplying by negative 4. This problem does not necessarily mean subtracting here. We're multiplying by negative 4 here to the x. So I'm going to undo this addition by subtracting 7 on both sides. So I have negative 4x equals 24. That was my first step. My second step now is I'm dividing by negative 4. And notice when I divide, I only divide by the coefficient, the number in front of the x. I do not include the x when I'm dividing. That's a mistake that a lot of people will make. So I divide, negative 4 divided by negative 4 is positive 1, so I have 1x is equal to negative 6. And there's my solution. I could take my answers and plug them in just to double check. So if I plug in negative 6, negative 4 times negative 6 is positive 24, and then 24 plus 7 is 31. So my answer looks good. Let's try a couple more problems. I'm going to shift up so we can see these problems. All right, so our next one here, we've got k over 3 minus 11 equals negative 5. So we locate the variable, and we're still following our same steps. We're going to undo what's going on. So this one just has a division here, but we have minus 11 that we have to take care of first. So I'm going to add 11 to both sides first. K over 3 equals 6. And now the undo of division is multiply. So the way I show multiply is I do a dot for times. I'm going to times both sides by 3. Because what happens here on the left-hand side is that these reduce. 3 divided by 3 is 1. So 1k equals 18. So I could plug that in. 18 divided by 3 is 6. And 6 minus 11 is negative 5. Let's take a look at 2 more examples. We'll do another fraction problem. So r over 2 plus 17 equals 25. We're going to follow the same steps. So to undo this, I have to subtract 17 because I located my variable r. It's being divided by 2 and adding 17. So I'm subtracting 17 on both sides. So I get r over 2 is equal to 8 because 25 minus 17 is 8. And then I multiply both sides by 2 to clear out that denominator. This reduces. R equals 16. So 16 divided by 2 is 8. 8 plus 17 is 25. Let's take a look at one more example that's just written a little bit differently, but I want you guys to see that it's the same process that we're following. Actually, I think we might do 2 more examples. So we'll label this one number 5. And this problem will be 8 equals 23 minus 5w. Okay, so take a look at this equation, because notice it's written differently than the problems we've seen already. Here, this time the variable's on the right-hand side, and then the numbers are written in a different order. That's okay. So we can still figure out what we're doing here. I've got 23, and then it's minus 5w. So what's happening here is I'm multiplying w by negative 5, and then really I'm adding 23, because 23 is positive there. So to undo this, I have to subtract 23 from both sides. So a common mistake is people will look at this and think that they should be adding 23. But remember, you're trying to undo what's happening here. So if you add 23, it won't go away. The goal is to make this go away. Because now I've got negative 15 equals negative 5w. And here I can divide by negative 5 on both sides. So 3 equals w. And plugging that back in, 23 minus 5 times 3. 5 times 3 is 15, and 23 minus 3, or 15 is 8. So that's how I know I did that one okay. We'll look at a problem that looks like this with fractions. So we have negative 6 equals 1 plus n over negative 4. So same idea, it's similar to the problems we did before, it's just written differently. We need to undo what's happening to the n. So we're dividing n by negative 4, and 1 is being added to it. So 1 here is positive again, so I'm going to subtract 1 on both sides of the equal sign, like we worked on with the one-step equations. Negative 6 minus 1 is negative 7. Those ones reduce or cancel out. So I have negative 7 equals n over negative 4. So I'm dividing by negative 4. So I have to multiply both sides by negative 4. So on this side, they'll reduce. 28 is equal to n. So that's solving two-step equations. We're just combining the steps that we learned before and applying it to get our solutions. So now you can try those practice problems in class.